Back to my channel. So today I've come with a new video in physics, and the name of the topic is force and pressure. So in today's video we are going to learn about the basic concepts of force and pressure, and we are also going to learn about the units of force and pressure. Okay, so today we will be at first learning about the definition, and then we will be learning about moment of force, a new topic. Okay, so before learning about pressure, at first let us learn about force, then we will learn about pressure. Okay. So force is an act of push or pull which changes or tends to change the state of rest or uniform motion of a body. I'm going as per my reference material. Okay, in the order in which I have set my material, I'm going according to that. So force is an act of push or pull. Okay, suppose this is the whiteboard. Suppose I have applied force. Okay, I've applied force. So what we can see, I'm pushing it basically. Now I'm pulling it. Right? At first I was pushing like this. Now I'm pulling. So force is an act of push or pull which changes or tends to change the state of rest or uniform motion of the body. So first it was in rest, right? When I have started pushing it, it came in motion. When I started pulling it, it also came in motion. So we are changing the state of rest. So force is an act of push and pull that tends to change the state of rest of a body or the direction of the motion of the body. Okay. Now coming to moment of force. This is a new topic. Moment of force is also called turning effect of force. Moment of force is also called turning effect of force. Okay, and this is also represented by tau, which is written like this. Okay, so moment of force, turning effect of force, or tau. Tau is the representative symbol, and these two are the synonymous name. Now suppose we take a body like this. And we pivot it at a point, or just fix it at a point. This is called your pivot. It's called a pivot point. Pivot point. Okay. Now suppose we are applying force like this. I'm applying force. So what we will see? The body starts rotating. It cannot move, right? Because it is fixed at this point. So it will start rotating. This is called turning effect of force. So it will start turning, right? So the turning effect of force about a fixed point or the pivoted point is called the moment of force or simply moment. Okay. So this is what is called your turning effect of force. That when we are applying force on a body which is fixed at a point, then it will start rotating. And this effect is called your moment of force or turning effect of force. Now if it is rotating clockwise, it is called clockwise moment. If it is rotating anti-clockwise, then anti-clockwise moment. Now coming to factors affecting the moment of force. Now first factor is perpendicular distance between the force and pivot. This is the first. And second, the magnitude of the force applied. So the distance, suppose I am applying force over here. So the distance between the force and the pivot is your first, and the amount of force that is applied, the magnitude of force, is your second. So these two are the main factors which is affecting the moment of force. So from here we can conclude one thing. Tau equals to force into perpendicular distance, or D. So if this perpendicular distance between the force applied and the pivot is D, and the amount of force applied is F, then tau equals to force into D. So we can say that more the amount of force, more will be the moment. More the amount distance, perpendicular distance from the force to the pivoted point, more will be the moment. So these two are the factors. So tau is directly proportional with force as well as directly proportional to perpendicular distance. Now coming to units of moment of force. Units of moment of force. Now perpendicular distance, we know distance is meter, right? The SI unit of distance. SI unit of distance. Distance means here it is basically the length. Length between the force and the pivot. That is only referred to as the distance. So that is SI, your meter, right? And SI unit of force is your Newton. So if this force, if it is N, and D if it is M, then we can say that unit of tau is N into M, that is equals to Nm. We can obviously say that, right? So this is the unit of moment of force. Now what are the applications of moment of force? The application are, it is easy to open a door by applying force at the handle provided near the free end of a door. It is because if the force is applied at the handle, the moment of force is large. Small force can produce a large turning effect. What is it trying to say is, suppose if this is the door, these are the pivoted point, and this is the handle. So handle is placed at the free end. So more the distance from this pivot, this is the pivot, right? More the distance, more will be the turning effect of force. So the amount of force applied will obviously less, right? Now if the handle is placed here, then we have to apply more amount of force since the distance is less. And here if it is, then we have to apply less amount of force, right? Now coming to few numericals. Okay, we will not be doing much numerical, only one numerical as an example I'll show. Calculate the force which will produce a moment of 40 Newton when the perpendicular distance between the point of application of force and the pivot is 40 centimeter. So what are the given information? Given tau, it's given 40 Newton meter, and what else is given? Perpendicular distance is given, that is equals to 40 centimeter. 40 centimeter. Now always we have to convert it into the SI unit. Okay, centimeter is not the SI unit, it is the CGS unit, right? So centimeter to meter means into 100. So it will be basically your, no sorry, by 100, so it will be basically your 0.4 meter. Okay, so since from centimeter to meter we divide the value of centimeter by 100, right? Therefore, wait, it is not visible. Okay, so if something in centimeter is given, so in order to convert it into meter, we divide it by 100. So what we have did here, 40 by 100 equals to 0.4 meter, right? Now, what we know about the formula, that tau equals to, I'm just rubbing this upper portion, tau equals to force into distance, right? This is the formula. Now from here, can we say that force equals to tau by distance? Simple linear equation. Force equals to tau by distance. Okay. So, therefore, force equals to tau by distance equals to 40 by 0.4. This is Newton meter, this is meter. Meter and meter gets cancelled. So we are left with 40 by 0.4 Newton, that is equals to 100 Newton. So 100 Newton of force will, with a distance of 40 centimeter, will apply a turning effect of 40 Newton meter. Okay. Now coming to pressure. This was all about force. Now, pressure is the amount of force applied on a on an area. Amount of force applied on an area. Okay. So, I'm just reading out my reference material 1. Smaller the area on which the force acts, greater is the effect of force. Suppose you take a pencil. Suppose this is a pencil. This is the pointed end and this is the back side of the pencil. If you put pressure through this side on your finger, will it hurt you? No. But if you put pressure from this pointed end on your finger, then obviously it is going to hurt you, right? So, see, I have used the term pressure. So, what we can conclude from here? Less the area, more the pressure. Less the area, more is the pressure, right? Because here the pressure, the area was quite less, but here the area was quite more. But here we have saw, being the area being less, the pressure produced was much more. Therefore, we saw that the pencil which is used over here is applying more pressure when we are, bringing our finger towards the pointed end, right? So can we say this, that pressure equals to force per area? Can we say this? Amount of force per area is your pressure. Okay. So, pressure is first of all a physical quantity. Now, pressure is defined as the amount of force acting per unit area. Mathematically, pressure equals to force by area. The total force acting on a given surface is also known as thrust. Okay, the total force which is acting. Okay, thrust can also be called the perpendicular force acting. Force acting in a perpendicular way, or the total force that is acting on the object or on a particular area is your thrust. So we can also say it as thrust. Okay. Now, what are the factors affecting pressure? First, magnitude of the force. Second, magnitude of area. Right? What we know? We know that more the area, lesser is the pressure. So we can say that pressure is inversely proportional to area. Can we say this? Obviously we can say. Pressure is inversely proportional to area. Now, we can also say that pressure is directly proportional to force. We can also say this. Pressure is directly proportional to force. Right? So these are the two factors that is affecting pressure. Now coming to the units of pressure. We know the SI unit of force is Newton, represented by N, and SI unit of area is meter square, represented by M. Right? Meter square. Therefore, pressure equals to Newton bar meter square. That is also it can also be written as in this format, Newton per meter square. Now Newton per meter square is also called Pascal. So we can say that unit of pressure is Pascal or Newton per meter square. Okay, Pascal, it is represented by PA. Clear? Let us solve one numerical. A box weighing 100 Newton is placed on a wooden plank such that the area in contact between them is 2 meters squared. Find the pressure exerted by the box on the plank. So, what are the information given? What is given? First, force equals to 100 Newton and your area in contact equals to 2 meters square. Right? Now we know we have to find the pressure. We know pressure equals to force bar area. Therefore, pressure equals to, since pressure equals to force by area, therefore pressure equals to 100 by 2. 50. Therefore, 50 Newton per meter square or 50 Pascal. Clear? This will be the answer. Now coming to application of pressure. Increasing pressure. Knives, blades, scissors, saws and axes have sharp edges. A sharp edge has a smaller surface area. Obviously a sharp edge, like the lid of the pencil, the sharpened side, it was having a sharp edge and it was having a less area. Therefore, even a small force results in greater pressure and can cut a substance easily. Like for a knife, the sharp side has a less pressure and it can cut through the fruits, vegetables easily, right? Now, decreasing pressure, high-rise buildings have massive weight and thus apply a large force on the ground. In order to reduce the pressure exerted by them on the ground, they have a broad base. Okay, so they have a broad base to spread the force on a large area in order to reduce the pressure, as massive rise means high-rise buildings have a massive pressure applying on the ground. Okay. Now coming to the pressure exerted by liquids. Pressure exerted by liquid. Now, in case of pressure exerted by liquid, we have few characteristics. Okay. First is pressure exerted by liquid. Okay. Suppose this is a vessel where water is there. Now, water gives some pressure on the walls of the vessel. These arrows represents the pressure applied on the walls of the vessels. Pressure applied on the walls of the vessels. So this, and water is obviously a liquid, so we can say it is as a liquid. This pressure applied is called lateral pressure. Lateral pressure. This pressure exerted by a liquid on in the walls of the vessels is called your lateral pressure. Now, liquid pressure can be used by a device called manometer. Okay. Characteristics of liquid pressure. Coming to the characteristic features of liquid pressure. What are the characteristics of liquid pressure? First, liquid exert pressure on the walls of the container. Liquid exert pressure on the walls of the container. That is your lateral pressure. Second, the pressure exerted by liquid is directly proportional to density. So liquid pressure is directly proportional to density rho. So more the density, more is the liquid pressure. Third, pressure exerted by liquid increases with depth. So liquid pressure increases with depth. That's why in oceans and seas, it is found that on the top portion the pressure is not much, but if the top portion and means on the top portions the things means the pressure exerted is not much. Okay, like here if we say it is not much, here the pressure will be less pressure, but here below it will be a high pressure. Okay, so pressure increases with depth. Now liquid exerts pressure at this liquid exerts the same pressure in all direction at a points lying at a given depth inside the liquid. So fourth is liquid exerts pressure on the points lying at the same depth. Okay, and last but not the least, liquid seek their own level regardless of shape and size. Okay, liquid seeks their own level regardless of shape and size. Now coming to Pascal's law. Blaise Pascal was the person, okay, full name is Blaise Pascal. According to Pascal's law, whenever a pressure is applied at a point on an incompressible and a confined liquid or fluid, it is transmitted equally in all possible directions with undiminished magnitude. That means these were the characteristic features, okay? Suppose what Pascal's law state is, suppose we have a container like this which is sealed and it is fixed, fully filled with water. And we have holes like this. Now we started applying pressure using something. We started applying pressure like this. It is found that the pressure gets equally transmitted at all possible directions. Okay, and water will flow out of the liquid through these holes. And not even if these holes are not present, it is found that all the points on the liquid or on the vessel, the liquid, applies the same pressure. Okay, so this pressure gets equally distributed. These are the pressures. Okay, so they get equally distributed. Okay, now consequences of liquid pressure, we will only focus on one consequence, the important one. Deep sea scuba divers have to wear special suits to protect themselves from being crushed by the high liquid pressure in deep ocean. So as I have already told you that in deep sea level, deep sea divers have to wear a special suit which protects them from the crushing effect. Otherwise, they will implode. Okay, due to the huge pressure of the ocean and the seas at deep levels. Now let us come to the pressure exerted by gases, atmospheric pressure, and this is our last topic. Okay, atmospheric pressure. Now this was the pressure exerted by liquid. Now we will be seeing pressure exerted by gases. Pressure exerted by gases. So pressure exerted by gases. Now we have a term called atmospheric pressure. Okay. Now let me read out one thing. The earth is surrounded by 300-kilometer thick layer of various gases known as the atmosphere, as we have already know. Okay. So we have a thick layer of atmosphere like this around the earth. If this is the earth, this layer is called your atmosphere. It's a 300-kilometer thick layer. 300-kilometer thick layer which is held to the surface of the earth by gravitational pull and exerts a force on it. The force exerted by the atmosphere per unit area on the surface of the earth is called the atmospheric pressure. So what is atmospheric pressure? Atmospheric pressure is the amount of force exerted. Suppose this is the earth's surface, the top portion of the earth, and atmosphere is present here. It exerts pressure on the earth, right? So the amount of force exerted by the atmosphere per unit area, this is the unit area, right? Per unit area on the surface of the earth is called your atmospheric pressure. The atmospheric pressure exerts pressure in all directions, and in SI unit its value is about 101,325 Pascal in SI unit. The atmospheric pressure is value at sea level. Okay. So let us come to one consequence of atmospheric pressure. Atmospheric pressure decreases with an increase in the altitude. At higher altitudes, the pressure inside our body is greater than the atmospheric pressure. This is the reason why mountaineers suffer nose bleeding at high altitudes. Basically, on the Earth's surface, the atmospheric pressure is very much, and the blood pressure, and simply let us call it our body pressure. The body pressure inside that is present inside our body is balancing the atmospheric pressure. Otherwise, we would have been crushed. Okay, but when we are reaching at a high altitude, their atmospheric pressure becomes low. But at that point of time, we find our body pressure becoming higher, right? There is no one to suppress the body pressure. On the earth's surface, it was suppressed by the atmospheric pressure and it was controlled, it was balanced. But there, who will suppress it? Who will balance it? Therefore, body pressure becomes much more than the atmospheric pressure. That's why mountaineers suffers nose bleeding, as the pressure tends to, push blood outside the body. Since it's a blood pressure, as I've already told you, so mountaineers therefore suffers nose bleeding. So with this, we complete with today's lesson. Hope you have liked my video. If you like my video, please like, share and subscribe it. Also press the bell icon to get the notification of my uploaded video. And hope today's topic is very much clear to you. See you all in the next video. Bye.